Hello everyone watching this video. My name is Ainaman Jordan Best, pursuing a program of information technology at Muni University, and today we are going to be talking about let me say the course of uh, project management in computing. Recently I've been studying this course on allison.com, so I may recommend anyone watching this video and is maybe like a student to go and then try to learn some things about project management and the other things on allison.com. I will put the link in the description. So today we are going to be talking about some key areas of this course. So I can explain project management in computing as maybe a structured approach of planning and maintaining software projects. So it ensures that software development aligns with the business objectives, meets deadlines, and stays within the budget. So when you are having a project as maybe an IT based company or any other company that has that IT department in it, so you'll be having projects that need to work on, mostly maybe like websites or applications. So here project management comes in to work on those projects, and we shall be looking at key areas that will be helping us during like working on projects. So this project management course will be helping us to get more ideas, skills in working on projects and maintaining such projects. So we need first to know about what are the software projects or types of software projects. So software projects can be classified into categories based on their purpose, and common types may include custom software development, system software projects, and embedded software projects. We can also have web development projects, AI and data science projects, since now AI is now the trending thing in the IT sector. So we can also have projects about AI. So custom software development, this includes solutions for specific business needs or personal needs. Then system software projects, this can be operating systems, firmware, and device drivers. Yeah. Then embedded software projects, we can have software for IoT devices, industrial machines, and maybe real-time systems. Then web development projects, these are basically websites, web applications, and e-commerce platforms. Then we have enterprise software projects. These are large-scale solutions such as ERP, which is enterprise resource planning, CRM, which is customer relationship management, and HRM, which can be human resource management. So we can be developing software that will be dealing in such areas. Then we can talk about activities in software project management. Software project management involves several key activities to ensure a smooth activity or execution. So here we may have project planning. Here we define the project scope, timeline, budget, and anything that will be in that project. Then requirement analysis, where we create documents like what maybe users need. Then we can talk about system design and architecture. Here we structure the software components and how that software will work, or the workflow. Then we can have implementation and coding. Here that's when we start writing the actual code for the system using programs like Python, JavaScript, web-based programming languages like HTML, CSS, and whatever. Then we can have risk management. Here it's where we identify the risks and then find a way of mitigating those risks. Then we have quality assurance. This is where we test the software for bugs and performance issues. Maybe here we can have some users, some small sample of users to come, and maybe we check the functionality of the project, and then if there are issues, we try to solve those issues. Then we have deployment and maintenance. So here, that's when we launch the software and ensure the long-term support for the software and for the users who are using the software. So now let's talk about life cycle models in project management. A life cycle model outlines the process a software project flows from start to finish, and the most common life cycle models include a waterfall model, and in this model, it is a traditional sequential software development approach where process flows downward like a waterfall. That's how it is basically stating it, and it goes through different phases, and it is best suited for projects with a well-defined requirements and maybe minimal expected changes. So phases in the waterfall model may be we have to first do analysis. Here we gather and document all system requirements before we can proceed, and then next we do system design. Here it is the architectural and technical designs are created based on requirements, and hardware software specifications may be defined on this stage, and next we are going to do the implementation or the coding, and here developers write the actual code using the other programming languages, Python, JavaScript, Java, and all the web-based programming languages. And then after we have made the project, now we go for the testing. So here the system is tested for bugs, performance issues, and maybe possible errors. Then after we go for the unit testing, here we do integration testing, system testing, and user acceptance. Yeah, so then after that stage we can do deployment, and this is where the project is given out to users for use. So after that we can go for the maintenance and the bug fixes, updates, and enhancements based on the user feedback, how the users are feeling about the software. So if issues arise, then we go for maintenance and fixing such issues. Advantages of this cycle model: it is simple and easy to use, and best suitable for small and well-defined projects, and it may have a clear documentation at the start. Then for the disadvantages, it has a rigid structure, like difficult to make changes, and late stage testing. It may not be suitable for complex or evolving projects. So secondly, we have a V model, or verification and validation model. So this model is an extension of the waterfall model but emphasizes testing at every stage of development. Each development phase has a corresponding testing phase, forming a V shape. So phases of the V model, we have first requirement analysis, system design, architecture design, and module design, and coding and development. So advantages of this model may be early defect detection, since testing is integrated at each stage, and it has a well-structured and a disciplined approach. And this model, it ensures quality at every phase. Then disadvantages of this model: it is not flexible. Changes in requirements are really costly, and it requires extensive planning, and most probably it is time consuming for large projects. Then on the third model, we have the spiral model. The spiral model is an iterative, risk-driven development approach that focuses on risk assessment and project prototyping, and it is ideal for large and high-risk projects. Phases of the spiral model we have: planning, risk analysis, engineering, and evolution. So in planning, here we identify the system requirements. Then in the risk analysis, we evaluate the potential risks and we decide mitigation strategies. Then in the engineering part, we do developing the prototype of the software, testing and integrating it with all the required systems. And in the evaluation, customer feedback is taken and it is used to refine the product in the next cycle. So advantages of this cycle: it handles changes requirements efficiently, and risk management is a core part of this development. And then it has continuous user feedback, ensuring better and product quality. Then disadvantages: expensive due to repeated iterations, and it is complex to manage, and it requires skilled project management. Then we also have the agile model. So this model, it is an iterative and incremental approach that focuses on flexibility, collaboration, and customer feedback. So here development is done in small iterations with continuous testing and feedback. Advantages of this model: it is adaptable to changing requirements, and it has a fast delivery and continuous improvement. It also encourages customers and stakeholder involvement. Then disadvantages: it requires active user involvement, and it is not suitable for projects with fixed requirements. On the fifth, we have iterative and incremental model. This model combines aspects of both iterative and incremental development. Here, instead of delivering the complete system in one go, small portions of the functionalities are developed and improved over multiple cycles. Phases of this iterative and incremental model: we have planning, design, implementation, testing, and evaluation. Then advantages of this model: it is more flexible than the waterfall model. It is easier to manage changes and improvements, and the delivery of the software may be at an early stage, allowing user feedback. And disadvantages: it requires careful planning and management. And here, integration between iterations can also be challenging, and this model, it is not suitable for small projects with a well-defined requirements. Any company trying to develop a software can use one of these cycle models that best suits their project. So here we may say project management in computing is essential because it ensures successful execution for software projects.